Good morning to all. I am Dr.B.Angelin, Assistant Professor, Department of Information Technology, working in Dr. S.N.S. Rajalakshmi College of Arts and Science. Now I am going to discuss the paging and segmentation in operating system. Semaphores. Paging is a memory management technique in operating system that enables the processes to access more memory than is physical available. The system improves performance and resource utilization, and it reduces the risk of a page faults. This method is also known as a swapping in Unix-like system. Physical memory. Physical memory is divided into fixed size blocks. It's called a frames. Logical memory is divided into blocks of the same size. It's called a pages. A frame has the same size as a page. Physical memory is a place where a page can be placed. Memory management technique that permits the physical address space of a process to be non-contiguous. Every address is generated by the CPU is divided into two parts. One is the page number and second one is page offset. Addresses. The page number is used as an index into a page table. The page size is defined by the hardware. The size of page is typically a power of 2. It's varying between 512 bytes and 16 MB per page. For reason, if the size of a logical address is 2 power m and page size is 2 power n, then the high order m minus n bits of a logical address designate the page number paging hardware. Paging hardware. When we use a paging schemes, we have no external fragmentation. Any free frames can be allocated to a process that needs it. However, we may have internal fragmentation if the process requires n pages. At least n frames are required. The first page of the process is loaded into the first frame listed on free frame list, and the frame number is put into page table paging examples. Paging, the simplest method, is to implement the page tables as a set of registers. However, the size of register is limited and the size of page tables is usually large. Therefore, the page table is kept in main memory. If we want to access any location, we must first index into the page table. This requires at least one memory access. The standard solution is to use of a special small fast cache called translation look aside buffer or associative memory. If the page number is not in the memory, reference to the page table must be made. In addition, we add the page number and frame number into TLB. If the TLB already full, the operating system must select one for placement. Some TLBs allows entries to be wired down, meaning that they cannot be removed from the TLB. For example, kernel codes. The percentage of times that are a particular page number is found in the TLN is called hit ratio. If it takes 20 nanoseconds to search the TLB and 100 nanoseconds to access a memory. Advantages: no internal fragmentation, simple memory management algorithm, swapping is an easy, and share a common code especially in a time sharing environment. And disadvantages: internal fragmentations, page tables may consume more memory. Multi-level paging leads to memory reference overhead. There is another way in which addressable memory can be subdivided. It's known as a segmentation. An important part of the memory management is that become unavoidance with the paging is the separations of the user view of the memory and the actual physical memory. The user view is mapped to the physical memory. Thus, the differentiation comes between the logical and physical memory. The user view memory as a linear area of bytes, some containing instructions and other containing data. Logical addressed spaced segment number offset. The mapping of the logical address to the physical address is done with the help of the segment table. Segment limit, segment base, other bit is needed to determine if the segment is already in the main memory. Another bit is needed to determine if the segment has been modified since it was loaded in a main memory. The length of the segment table starting address of the corresponding segment in main memory. Internal and non-external. No internal fragmentation segment tables consumes less memory than pages tables. External. Its costly memory management algorithm, unequal size of segments, is not good in the case of swapping. Already we see paging segmentations. Thank you.